Okay, good morning. I really appreciate everybody taking the time to join us this morning for an overview of 3D in PD&E Guidebook. I'm Catherine Bradley, the State Environmental Development Engineer with the Office of Environmental Management. And as you probably know, the department is moving towards using 3D plans in design. So as a result of that, we wanted to explore using 3D concept plans in PD&E and to make our handoff better between design and PD&E. Have concept plans that are more useful for design. So that's the purpose of this training. So let me go ahead and go to the next slide, please. So before we get started, just a little bit of housekeeping. This webinar is being recorded and it'll be posted on the FDOT website. And this will allow others who wanted to attend but couldn't view at their convenience. So during the webinar, if you have questions, please feel free to put them in the question box, and our team will monitor the questions as they come in and address them at the end of the webinar. So next slide, please. So in this hour, we're going to give you a little bit of background of the purpose of using 3D and PD&E, and we'll also highlight the benefits of using 3D, then walk you through an example project using 3D and PD&E, and discuss some of the challenges in the workflow process and the workflow process. And next slide, please. So at the end of the presentation, we'll walk through the 3D and PD&E Guidebook. The guidebook includes topics such as current guidance in 3D, software tools, incorporating 3D in the PD&E design scope, schedule, and budget. And so now let me introduce our two presenters. We have Eric Gray, he's the National Director of Digital Design for Atkins North America, and Lauren Bowes is a PE, is Project Manager and Senior Transportation Engineer for Atkins. And with that, I'll turn it on over to Lauren.
Thanks, Catherine. Next slide, Eric.
Are you able to see the introduction slide?
There's a lag on my side, so.
Okay.
There we go. All right, good morning, everybody. Thank you, Catherine, for the introduction. As PD&E practitioners across the state, we understand that the PD&E study process considers several design alternatives during the concept plans and alternatives analysis. There is a lot of time, expertise, and effort that is spent developing and evaluating those concepts and alternatives before a preferred alternative is selected. During the PD&E study, several exhibits are developed using a variety of tools, including GIS, CAD, and available survey, and that information is put together to convey the design intent to the public, as well as the subsequent design team, as Catherine mentioned, the handoff between PD&E and design. So we are seeing more and more that the design phase is moving into 3D design and deliverables, but PD&E, we haven't seen that change as much, and the concept and alternatives analysis has remained relatively unchanged to this point, but we're starting to see that transition that Catherine mentioned, and we're going to talk about that a little bit more as we go through this presentation. OEM has also reviewed current district practices, so you'll see throughout the presentation and the guidebook that is posted that we have surveyed the districts across the state and talked about how to incorporate 3D and PD&E, how folks might already be doing it, and any best practices that we can incorporate into PD&E to utilize 3D tools and data. With that, I'll turn it over to Eric, and I'll come back and chat with you guys about the guidebook at the end of the presentation.
Well, good morning, everybody. Thanks, Lauren. Thanks, Catherine. So let's talk a little bit about the purpose of using 3D, right? So the purpose of this particular guidebook is to publish guidelines and some best practices, right? So it's not a standard at this point, but it is a guidebook and produces some guidelines and best practices for the implementation of 3D during our PD&E projects. And what's the outcome of that? We're looking for efficient transfers of data from PD&E phases to the final design phase. And so what we are encouraging is that where appropriate, the PD&E teams can be encouraged to utilize FDOT's CAD standards and applicable guidance, right, which includes the 3D design manuals and the guidance and training materials that are out there currently to begin to help facilitate seamless transfers into the design phase. So I want to walk you through a little bit of the overview of the life cycle efficiencies, right? There's a lot that we could be doing better. And I want you to focus in on this area here, which is where we are trying to make the most change around the PD&E 3D delivery, right? And these changes that we're making, there will be some increases in the time that it takes, right? But we're talking hours and days, not weeks and months. So let's talk about some of the data we currently already receive. We're already aware of survey data, Lidar, layers, and GIS, right, data. We collect all of this information and we bring it into our PD&E processes. But a lot of times we're not bringing across or leveraging the 3D data that's currently out there. So that's something we want to increase. We want to increase our use of that 3D available data. And a lot of people think about, the cost that's associated with survey. Well, and especially during the early phases, you don't have funding for significant amounts of survey. And that's where a lot of this freely available data can be beneficial. Okay, especially if we're utilizing some of these tools that we're going to talk about a little bit later. You'll hear us talk about rapid 3D modeling tools or detailed 3D modeling tools. We'll talk about how those applies, and the manual really gets into that as well. So we bring this information in currently, right? And if we were leveraging the 3D, we could begin to develop corridor modeling, right? Whether it's through Open Roads Designer or whether it's through Civil 3D. And this has dramatic impacts on our optioneering and on our visualizations and public outreach. And what does that mean? It means that we have the capability to provide higher quality and higher accuracy even early in the design process. So what happens next? If we begin to incorporate this 3D information here, we're already passing some data forward into the plans development phase, right? But if we're passing 3D data from PD&E, we're able to positively impact our plans production, especially as we're moving into next gen delivery, which is now the requirement. So all of our new projects as of January of 2021 should be leveraging the Open Roads Designer or Civil 3D as the platform in which to develop their projects. Contrary to popular belief, if you are designing in either of those platforms, you are utilizing next gen plans. And what does that mean? That means that section 900, it applies to your projects. So keep that in mind. If we're utilizing Open Roads Designer or Civil 3D for our production environment, we are developing next gen plans. So if we're doing a better job here of leveraging 3D in the PD&E, we're able to pass a lot of valuable content into this design phase that the team can pick up and continue forward. And we can talk about that a little more. I won't belabor it here. But what is the benefit of next gen here? Next gen has already proven that we can provide AMG, we can provide for fewer changes, and we can provide more accurate cost estimates, right? Because we're actually dealing with real modeled data. We are comparing our designed surface, our design model, to a surveyed surface at that phase of the work. And so that is very beneficial to the construction phase, right? And this, whatever we're learning during this construction phase about what we're passing through, right? We're still in a learning process as we begin to expand our capabilities and our interoperability and our collaboration with the downstream recipients of this information. But as we learn more, that influences how we do our designs here. So, and what does that mean? As we adjust in that phase, that means that we're able to provide even further savings during construction. So you might notice that with all that we're demonstrating here, there's a little bit of a left shift, right? That's what you're seeing. A lot of this stuff, it needs to happen earlier in the process, or we need to begin to think about ways to support earlier decision making. So let me describe this to you.
Hey, Eric,
Sure.
before you go on, we had a question about an acronym. Can
Okay,
you
sure.
define what AMG is?
Thank you. That is automated machine guidance. Okay, so if you've seen like the equipment when you have the dirt movers out on the project, and you may see the little disc, right? It looks almost like a little saucer that sits out just on the forks of it, or just on the tip of the machine. That is a GPS. That is a GPS device, and it is communicating with whatever they've triangulated in the area for their control, and it's telling the blade, okay, the screed or whatever the apparatus is, where it needs to be in relation to the world in order for it to create or grade to that design that's been produced. So very good question. I'm sorry I didn't give you that earlier. Yes, AMG is automated machine guidance. Thanks, Catherine. So let's talk about some processes here. So this is considered the Mclamey Curve. What is that? What is a Mclamey Curve? You can see it's dated somewhere around 2004. Now, we did make a couple of modifications to it just so that the nomenclature aligned to what we do and some of the projects, the way that we progress our projects through a program, right? But the Mclamey Curve was developed by Patrick Mclamey, okay? Patrick Mclamey is an American architect, and he was formerly the chairman and CEO of a global architecture and engineering firm by the name of HOK. Many of you may be familiar with them. He currently serves as the chair of Building Smart. Now, that name may not be familiar to a lot of people, but it will become in the coming years. Building Smart is an international organization whose primary objective is to improve the exchange of information between software applications. So you may be familiar or have heard people talk about IFC format, right? Which is Industry Foundation Class. And what it is an open source language in which all of these separate applications like Autodesk or vendors like Autodesk and Bentley, Trimble can all communicate with. You've heard Vern and the central office talk about a lot that we want to move away from having these specific applications, right? We want to be application agnostic, right? So that is where we're heading. IFC helps us move in that direction. You may think of other formats that are application agnostic, similar to like XML format. We're able to transmit alignments and surfaces in XML, right? But IFC will allow us to translate models between platforms. It doesn't matter if you were in Bentley or if you were in Autodesk or any other. It is an open source format so that we're able to more effectively communicate with other applications. So the vision that he had here, and look at this was 2004 when this curve was developed. And I feel like it's finally finding its true space and its realization in the time in which we live. He realized even then, if we take a look at this blue line, this is our ability to impact cost and performance, right? So look at this. Along this side, we've listed effect, cost, and effort. So at the beginning, that's high, right? But as we progress through those phases of our project, our ability to impact cost and performance drastically reduces. However, the cost of those design changes is in exact opposite to that. It's low at the beginning, but as we're later into the phases, into construction and maintenance, the cost of those changes goes up quite significantly. If you look at where we currently place our processes, right, our traditional design processes, there's a lot of cost and effect and effort that's put in during the final design and specifications phase, right? But what happens if we are staying here, we're not getting the best benefit out of the information that's available or making the best use of the resources. He envisioned that it would be really beneficial for us to begin to think about shifting that decision making to an earlier point in the process. That's why it's considered a left shift, okay? Where we put a lot more effort into doing a lot of these activities during the PD&E and early design phases, so that when we are into final design and specifications, the cost, we're under that curve, right? If we look at where this inflection point or where this intersection point exists, we need to be underneath that in order to make the best use of the funds that we have been allocated as a public entity. So this is something for us to think about. And there are some strides that are being made even with FDOT, with some of the processes that are currently in place right now with our, let me give you the name of it, where we're utilizing PD&E, concurrent PD&E and design phases. So you're going to see a lot more of this because it's a more effective use of our resources if we take care of those decisions earlier on and then leave that detailed processing. A lot of that the decisions have been made earlier, right? If we take care of them in the PD&E and early design, then we're focused on detailed design, refining of the design, right? But not major design changes that will be drastically more expensive than they could have been earlier in the process. So what does that mean? That means that we need to change the way that we accomplish our processes, the way that we do our work, right? So what we have outlined here at the top is our typical PD&E workflow, right? It starts with data collection. We have base maps and project location map development, typical sections and graphical typical sections, alternatives analysis, concept plan generation, visualization and fly-throughs and reports. And we have public involvement that is going on all throughout that process. So how do we currently accomplish that today? We extract that 2D data from repositories. That could be GIS, it could be survey, it could be record drawings. We consume that collected data and develop in traditional 2D CAD platforms. And then we produce flat or 2D graphics and visualizations as our deliverables or as insertions into our reports. So in order for us to change that, let's add in 3D and see what that does and how it improves our future. So instead of simply extracting 2D, let's extract 3D data from repositories. Sometimes it's the same sources. We've become very accustomed to going to the GIS repositories, but we seldom utilize the 3D data that is there. So let's start extracting that data and let's consume that collected data and develop it in a rapid 3D modeling tool. So I said I'd give you a little more information there. A rapid 3D modeling tool, if you're familiar with some of the platforms that are out there, a rapid 3D modeling tool would be Concept Station from Bentley or the likes of InfraWorks from Autodesk. Our detailed 3D CAD modeling platforms would be the likes of Open Roads Designer, Open Bridge Designer from Bentley, and Civil 3D from the Autodesk side. So we wanted to categorize those, and you'll see that even in the report. in the guidebook, that we give you some other applications that fall into those categories as well, to help understand what tools are at your disposal. So now if we're utilizing those applications and that more advanced technology there, we're able to produce plans and graphics and visualizations as deliverables based on those 3D models, right? And our potential for more accurate data, or when we're cutting sections, when we're making assessments between surfaces and the lower members of bridges or any of that content, is going to be a lot more accurate if we're leveraging 3D. And so what does that mean? That means we have a more efficient handoff to the design phase, because now we can reuse that data. So even if you utilize the detailed 3D modeling tool, you developed an alignment and profile, let's say, and you've developed the templates, all of that information, if it's done in PD&E, is now available to your design team. And now they're only focused on refining and expanding what has already been begun, not necessarily having to redo it. So what's our benefit statement? Well, we want to enhance design during our PD&E processes. Why? Because it produces higher quality concepts and facilitates better decision making, right? If we have more accurate models and we are taking or have the capability to take samples or cross section or view data at a tighter frequency, that means that we can make better decisions regarding our end conditions, regarding a number of different elements that impact our projects. What is the benefit? Well, improving the handover process can reduce rework, minimize duplicative effort, and increases our efficiency, reduce costs, and positively impacts our project schedules. But of course, it does take a shift in the way that we think. So here are the benefits. If we start adding 3D into PD&E today, we may, right? Here are some possibilities. We will be able to save time on approvals due to higher clarity and accuracy of a corridor, right? We can increase our efficiency in plans production from models. It also enables more accurate and less costly visualizations. What do you mean by that? Well, instead of our visualization teams starting from flat 2D plans, you're passing them a 3D model that they just need to refine. So of course it does add some additional costs, but once again, as I was highlighting earlier, we're talking about hours and days, not weeks and months. And a lot of the benefits here, yes, there's more effort up front, but the benefit downstream is less required effort as we move forward. So what are the other things we may need to do? We may need to learn some new skills and techniques. We can't rely on the old tools we've been using for so long. We need to learn ORD, Open Roads Designer. We need to learn Civil 3D. We need to potentially involve some of the other colleagues, right, into some of the work that we're doing so that we can expand our knowledge base so that we can incorporate that into PD&E. Now, that's today. But if we look at the benefits in the future, by adding 3D to PD&E, it'll become the way that we do our work, right? It's easier because it's just the way that we produce it. That's the way we get the work done. It's faster because it's the only way we know how to do it, right? And what will we do as well? It'll allow us to collaborate in real time across our teams and stakeholders, right? So there's a lot of benefits there. Now, I wanted to give you an example. Now, this one's actually a little older. This is an example from a 3D in PD&E in District 5. I'll give you a little information about the project itself. So during PD&E and District 5, a basic 3D model would be produced, all right? 3D model would be based off of Lidar data, and most of D5 has Lidar information available from counties, cities, and other databases. So I just point that out to say that's true for most places. And that Lidar data typically has an accuracy of 1 to 2 feet vertically, right? Now there's a lot of different data out there, and you can refine that, choose what data quality or accuracy that you want to utilize on your project. But it's typically somewhere around 1 to 2 feet vertically. So we're going to take a look at this Northeast 25th Avenue project. And what we want you to take note of is where the right-of-way line is placed here, okay? Now, this is, of course, a finished typical section, but with the original layout from the team, just based on a 2D layout, as you can already see, the right-of-way was insufficient for the tie-ins that would be required. You can see this was a PD&E that was completed back in 2015. So on a 2-lane divided typical section. So let's see what happens. So this is a broader overview, and then we'll take a closer look a little closer down, okay? So if you can see on the screen, blue represents DTM information or survey data that we've received. Lidar is the free information that comes from any variety of sources that are out there. And PD&E is the limits that were provided from the PD&E layout. Now, all of these lines represent the tie-in points based on those surfaces, okay? So we use the same end conditions, and we simply tie it down to see where the correlations are and where there are some differences. As you can see, remember, once again, PD&E right-of-way is here. And notice that there is about, up to somewhere on the order of magnitude of about 20 feet of difference in some of these places between where our preliminary layout of right-of-way was in comparison to where it is in truth based on the DTM or LiDAR data. And if you look, there's not a lot of difference here. This is definitely enough accuracy for us to get started and utilize it as a good starting point for our PD&E design. Just something to keep in mind there. So I know we've talked a little bit about some of these rapid 3D modeling tools, right? So I'm going to walk you through one. Now, of course, there are multiple, right? The two that we talk about probably most prominently will be Concept Station and InfraWorks, just because they're the most prominent on the market. But whatever that rapid 3D modeling tool is that you're familiar with can be utilized in a similar fashion, okay? So I'm going to start the video, and I'll pause it at some places along the way. So what I wanted to note, it simply starts with typing in a location, right? I chose this region, and then now I'm just going to select the area that I want to develop a model around. I give it a name and then select the appropriate coordinate system for that data. Okay. Now, once that's done, notice that it goes through and we come to this point where I have the option of selecting the types of data that I want to bring in. I have terrain, I see static imagery, streamed from Bing Maps, roadway, buildings, and hydrology, right? So all of that information, it has access to automatically, and this is true of both of these rapid 3D modeling platforms, okay? Now, you can also supplement that with your own 3D data. If you have survey and it covers the area, you can utilize that instead. So you by no means restricted to this, but it is freely available if you have no data. Okay, so I'll move that forward. I'll select those boxes, and then you'll see what happens. It goes out to the Geo Coordination Services. You can see here where we're able to select the resolution, right? Low, medium, high with respect to that terrain. And then we just simply begin the process. It downloads it, and you'll see where it says success. And now we're able to move forward. So now we're inside of the view, and you can see the information, and the images will clear up as we move in. You see that it already brings in some semblance of roads in that particular area. Let's continue. So now we can go in and import some data as well. So what am I going to import? Notice we have some shape files out there for the parcel information. So if I want to be able to assess that, I can view that inside of this tool as well. So we select it, I choose it, I select the name, and say I want to bring it in for the entire project extent, allow it to come in, and now you can see it, right? Now, it may be a little overwhelming here in the view, but we can come in into the panels and simply turn that off, okay, until we're ready to work with that data. The next thing we want to do is come in and take a look at building a template for it. Now, we have some other work going on to simplify this part, but I want to show you how you can build a custom template inside of here that meets your needs, okay? So I'm just putting in a name here, and you see we'll use a 40-foot divided median. This is going to really speed up a little bit, and you'll see where I'm building that median condition, giving it a few names and setting those slopes so that I can be as accurate as I can with respect to what I'm modeling. Bringing that down, creating that separation, bringing in, and now I'm choosing striping, bringing in the shoulders, and also an unpaved shoulder. And you'll see we set the slopes on that. And then finally, you see we can see that we'll add in an end condition, just something simple, just so that we're able to tie in. After that's done, we can come in and simply choose the element that we want to place, choose a design speed. It uses the AASHTO information in order to determine your minimum horizontal curves, vertical curves, and all that information. So now I'm simply going to draw along here. And in this particular scenario, I'm imagining that the 2D, not 2D, the 2-lane roadway is being expanded to a 4-lane divided, right? So you can see how I'm attempting to overlap the existing there and also provide the additional 2 lanes in the opposite direction on the other side, okay? And now we can come in and adjust the horizontal curve information, you know, to suit our needs there. You could either type it in or you can adjust it manually. And you can see here we have a profile, right? So it's like, voila, we went from a simple profile there that was in there by default to something that actually includes K-value information. This information can be exported and utilized as well, okay, downstream. There's your XML files again. So after we've done that, okay, that's all well and good. Let's make a couple of modifications here. And then finally, we'll begin to start to look at what is the costing here in just a moment. We'll take a look at a cross section so that you can see it in that view. And this type of tool, once again, a rapid 3D modeling tool, is for the purposes of getting you to a design decision rather quickly, right? We can move along that alignment and view the cross section as necessary, right? You can see it moving along in the plan view as well. And we can also twist this around and take a look at it in a 3D view, which you'll see here in just a moment. And I just wanted to mention that because we have the ability, even from here, to export out to, let's say, Lumen RT or some other visualization application and add vehicles, add plants, or whatever. And it does not require a whole lot of effort or a lot of expertise from the designer's standpoint. So now let's take a look at, you know, what are the impacts, right? We were concerned about, okay, where I can see here that my new, that my widening, I can see exactly where it impacts the parcels that are outside of it. So I can go ahead and begin to make some decisions about what we need to do to address that. But we can visually see that within this rapid 3D modeling tool. So now, let's do some concept estimates. Notice here, based on everything that I've placed in the drawing for this particular concept, I'm able to see what that earthwork is. I know what the pavement is. And remember, even from the templates, we were able to expand the depth of the template as well. We could dial all of that in as necessary in order to give us the best numbers that we could get from a conceptual tool, right? But this is very, very useful. We also have the capability of exporting this out to an XML file. Not XML, I'm sorry, to a spreadsheet, an Excel file, where we can begin to utilize it however we need to in some downstream processes. Okay. And that'll bring us to the end of that part. So with that, we can take a few quick looks here at how we can challenge our PD&E workflow processes. You see once again along the left side that we've outlined the PD&E process and given a description of it. And what we asked ourselves as we began to develop this was, what are the improvements? How could we challenge these processes? Even during the data collection, what could change in data collection efforts to allow for 3D analyses and deliverables? Could we expand the use of that available data from common repositories, right? So all of this information, these challenges are provided for you inside of the guidebook as well. So I won't belabor that here, but just wanted to point that out. Let's challenge each one of these processes and see how we could begin to drive some additional efficiencies or gain some additional value from 3D content that is readily available to us. So let's talk about a few of these 3D opportunities at some of these phases and some of the efficiencies that we can derive from that. So once again, taking a look at data collection, here's a 3D opportunity. Utilize geospatial database software, GIS repositories. What can we do with that? We can analyze terrain information with point cloud data, land XML, 3D contours, existing 3D survey surfaces. We can even analyze our geotechnical information and visualize those soils in 3D. All of that is available to us. What is the efficiency that we get? We get a higher confidence in the feasibility of the PD&E design, which may result in fewer major design changes. And design can begin while official or additional survey is still being acquired. So we are able to do two things at once, right? Your design team can go ahead and lay out an alignment, a profile based on the available information while the rest of the more accurate survey comes in, and then we're just simply replacing the target of those end conditions and refining from there. Even with respect to our base maps and project locations, could we utilize 3D there? The answer is yes. So accurate exhibits can provide detailed insight into the design intent, right? So we won't be making guesstimates with respect to, is that representation that's come from the visualization group accurate, right? Is that really 19 feet up? Is that bridge really 19 feet up? It looks like it's accurate, but is it really? So if we're starting with 3D data, we can make sure that what we are presenting to folks is actually what they would see in the real world, as close as we can mimic it in our processes. Even in our typical section development, what are some of those efficiencies? Let me move on to just get into the efficiencies only here. The template and assemblies developed, can be reused and expanded during the design process, as we were talking about earlier. And this gets the design team moving and helps our design teams to shift their focus to confirmation. I'm just keep reiterating those points, right? Let's get some of those decisions earlier so that the design phase is focused more on refinement and confirmation of the design, not redoing the work. And all of that also impacts our alternative analysis. So our preferred alternatives have been developed during the PD&E phase has the potential to develop to a higher level of detail during the design phase, minimizing rework. So, and of course that goes on and on. So even our public involvement materials, I believe you're beginning to see how this can impact the way that we do the work that we do and our downstream tools and uses of that 3D information or even our exhibits. We even included a section here about reports. Now, we can begin to leverage 3D even in reports. Look at what we have in brackets when a higher level of accuracy is required to aid our analysis. So we can have more design confidence if that pun has really been designed, right? So if we lay that pun out as it actually is, we can get true volumes and from, if we're talking about surface water elevations, we're talking about seasonal high water, if we're talking about compensation, all of that we're able to do more efficiently if we're utilizing a 3D model. And with that, let's take some time to look in the 3D guidebook itself. So I'll pass that back over to Lauren.
Thanks, Eric. Before we jump into that, I wanted to real quick address some of the questions that have come
Okay,
through.
sure.
The first one was, will PD&E need to use ORD? Catherine responded that at this point, we're not mandating any changes with the PD&E process. This decision will be up to the district. And my understanding is that ORD is just one of the tools available, but if you have anything else to add to that, please feel free.
Sure, you're exactly right. We had some conversations around this when we were putting this together, Lauren, right? So it was the way we envisioned this was, let's say during your alternatives development process, you may utilize the rapid 3D modeling tools, right? Once again, that broad categorization there. And once you have your preferred alternative, then you could begin to utilize or consider utilizing the detailed 3D modeling to carry that forward from that point. So that's just one of the approaches there, how you could begin to leverage that and so that it begins to benefit the downstream phase. But yes, we're not required at this point, but we're strongly encouraging it just because of the benefits that it bodes for both the PD&E and also downstream users.
Great. We have a question here about the right-of-way acquisition process and how that's incorporated into the Mclamey Curve. I actually really like this comment, and it's something that I'd like to consider when we do our next update, was incorporating that into the Mclamey Curve. But to answer the behind the scenes question is, as we're making decisions earlier in the project process, more into PD&E and design, we're allowing that right-of-way phase to start earlier. It's going to be project specific. It's going to be, decisions made at the district level for each project. But hopefully by creating that opportunity to make better decisions or more informed decisions earlier in the project process, we're allowing for that opportunity for right-of-way to start their acquisition process earlier. Another question came through about utilizing, I'm sorry, where did it go? Vertical geometry not being included in PD&E right now. A lot of times the vertical geometry is not as much of a focus in the PER documents that we've seen coming in, but that's because a lot of Florida is fairly flat. However, vertical geometry is supposed to be considered during PD&E. So when you have extenuating circumstances, or if you're going to need to look at retaining walls or tie down slips for bridges and things like that, vertical geometry is supposed to be considered in PD&E. Utilizing these 3D tools will allow that to be more accurate and more obvious. So, okay, so my job here is to talk to you about the guidebook.
Let's see,
the 3D and PD&E guidebook.
Lauren,
that's okay. I'll share my screen here in just a second.
Okay.
I just wanted to go over this slide real quick. The guidebook was originally published in August 2021, and it is posted on the Office of Environmental Management Documents and Publications page. And I will show you that here now. Hopefully. Click to start screen sharing. There we go. All right. Can you guys see my screen?
Let's see. Yes.
Perfect. Okay, so if you were to click on that link that's in the presentation, or if you were to Google OEM's documents and publications, you come to this page. If you guys are not familiar with this page, it is an awesome resource of information for PD&E projects, everything from QA/QC to PER templates to all sorts of awesome, great information. The one that we're going to be talking about today is the guidance for using 3D technology in PD&E projects. So if you were to click on that, it would take you to the 3D and PD&E Guidebook. Can you guys see that now,
Yes.
Eric?
Yes, I can see it.
Perfect. Okay. So as we I apologize, technical difficulties here. When we pull this up, I went ahead and went through this document real quick. I know we've only got about 15 minutes. So I'm going to only go through some of the highlights, but this document is a great resource as you start to utilize 3D and PD&E more and more. Or if you have questions about how to start that, Catherine earlier went through our table of contents, and a lot of the information that we showed in the presentation today is also incorporated into this guidebook. So just to reiterate, the introduction of using 3D and PD&E, we're hoping to produce higher quality, more accurate concepts to facilitate better decision-making in PD&E by utilizing 3D and PD&E and improving the handover to design. One thing that, we're all really excited about this, but we do want to make sure that you guys understand that this is where appropriate or where the data is available. So this is utilizing 3D and PD&E is going to be a project-specific decision at this point. It is not being mandated. It is a guidance and a suggestion, strongly encouraged to utilize the information that's available today and the technology advances that we're seeing in the industry. All right, so scrolling through this guidebook, again, the purpose is to publish guidelines and best practices for the implementation of 3D into PD&E. This document is intended to be a living document. It is not going to answer every question that's going to come up on incorporating 3D and PD&E, but hopefully it'll give you a great place to start. And as we continue to learn more about this and start implementing it more, we will be updating this document. We're already working on some updates to come. All right. Incorporating 3D into PD&E right now, the general practice has been to use that for public involvement exhibits, but utilizing the 3D capabilities beyond that is still relatively new and not as common. So some of the considerations that we're going to have to do to start utilizing 3D and PD&E, as Eric mentioned, is to fill that knowledge and skills gap between PD&E and design. So as he mentioned, we can start learning more about those tools for our PD&E practitioners or start utilizing the team that is already utilizing those tools in the design phase. Explore and leverage more 3D data that is available, and then move beyond using 3D as simply a tool for public involvement exhibits. So now utilizing it more in our analysis as well. Excuse me. The overarching goal of this document is to provide high-level 3D guidance regarding the implementation of 3D tools, data, and workflow in PD&E. And those goals, reiterating again, were to maximize data reuse and efficiencies for the design phase, and to make better decisions in PD&E. Eric already went through this diagram really well during the presentation, so I'm not going to take too much more time there. Another way that this is already starting to be considered and incorporated for FDOT is the concurrent or combined PD&E and design with a new scope and projects that are being released with that. He already mentioned that. The Mclamey Curve. And then the second goal was to improve the analysis and decision-making in PD&E. The intended use of this guidance document is for all PD&E practitioners across the state, engineers, designers, planners, including DOT staff and consultants. And this document is meant to supplement the FDOT CAD manual and the PD&E manual. This is a guidance document. It is not regulation. Again, it's not mandatory yet. It is just being strongly encouraged. So as we developed this guidebook, we started looking for data. You know, we always do our data gathering at the beginning of a project, and we looked through several different DOT standards to find any information that we could about utilizing 3D in PD&E. So we looked through the standard scope of services, the PD&E, staff hour estimation guidelines, design, and the concurrent PD&E and design phase scopes and staff hour estimate and guidelines, the PD&E manual, the the DOT design manual, and the CAD manual. The FDOT CAD manual is a supplement for 3D and PD&E. Section 6.3 of the CAD manual provides some reasonable flexibility for the PD&E practitioner already. It states, where project alternatives and design concepts are developed using CAD standards where appropriate to facilitate a seamless transfer of PD&E CAD files to the final design phase. So the intent is already in the CAD manual. We're just hoping to encourage that. Again, just highlighting the 3D candidate deliverables. When you guys download this guidebook, these highlights aren't going to be there. Those were my tools for today to highlight our key points. One thing that Eric mentioned, but we'll show more here in the guidebook, is as we were developing this document, we took a survey and across the state from the different districts, and we got 31 respondents talking about 3D and PD&E. Some folks are already starting to explore this, but there is a statewide need to provide more guidance. So these types of screenshots you'll see are from that survey and the responses on whether or not they're already using 3D for preliminary design concept plans or just for fly-throughs and visualizations. And then we go into a lot more questions and data, but you can read about that in the guidebook. Talking about different data sources. On a typical project, what data sources did you utilize? So we started categorizing those into data types and then noted which ones have 3D capabilities. So utilizing those data sources that are out there, we tabulated them in their applicabilities to different things for PD&E, 2D, 3D, public involvement, and whether or not there's a cost required for some of the data that's out there. So that table is included in the guidebook. 3D software applications. We've already had at least one question about that. These are some of the software tools that have 3D capabilities, and this table talks about their requirements and some limitations to those. The next step is to identify PD&E deliverables and begin to draw general connections to those 3D tools. So you know there's a lot out there already, but how do we start using that in PD&E? So that is 3D applicability. This table, I think here, table 4-2, we're going to see evolve over time as we get more and more comfortable with 3D and PD&E and as we start finding more and more data available. But we broke down a lot of the PD&E deliverables that we see on most PD&E projects. This, again, you might have project-specific differences. But we broke them down into whether or not the deliverable had direct 3D applicability, potential 3D applicability, or unlikely 3D applicability. So as you can see, things that make sense to start utilizing 3D right now are things like concept plans, your plan profile sheets, base maps, typical sections, graphic typical sections, renderings, fly-throughs, and your geotech. That 3D information is already available out there. We're probably going to be seeing even more emphasis on the utility impact assessment report with utilizing 3D and PD&E and many of these other things, drainage, contamination, noise, all of that information has potential 3D applicability, and we're probably going to be seeing more of that in the future. And then of course there are some where 3D may not be as applicable, which is fine for now. And those are included as well. This is a breakdown of 3D applicability by PD&E manual section. So we broke down part 2 of the PD&E manual into whether or not it had potential or direct 3D applicability or unlikely. So the software tools and the PD&E deliverables matrix. This table is included in the report with some of those deliverables that we just talked about and how they can be delivered and the different tools that might be utilized to deliver those items. The example workflows, note that the traditional PD&E workflow that Eric showed during the presentation is fairly 2D centric, and we're trying to challenge that to start incorporating 3D into that project workflow with these steps that you can see in the guidebook. This is that diagram that Eric talked through and did a great job explaining that. Here is one that you guys can explore a little bit more, but it is an actual PD&E delivery workflow process utilizing 3D terrain, and it's broken down on the y-axis here with the different groups. The answer to this question of is there 3D terrain data available is becoming more and more yes. So as we continued this incorporation, this answer is more than likely going to be yes. Of course, there are still going to be exceptions, but example software tools and workflows. This should answer a lot of the questions that folks might have about what tools to use or which tools can be used. As software changes, this list might change as well, or as capabilities are added or whatnot to the different software packages out there. So as you move through the PD&E workflow process, these are suggestions of tools that you might be able to use during those phases of the project. One question that came up quite a bit in our early outreach was incorporating 3D into the PD&E scope, schedule, and budget. FDOT currently has 3D modeling in the design phase, but we had some suggestions here in the guidebook of how to modify that language to incorporate it into PD&E scopes. So we've already started that. Again, it's going to be project specific at the district level to make these decisions, but there are some suggestions included in the guidebook. And then the schedule and budget are definitely going to need to be adjusted to incorporate PD or 3D and PD&E, but note, again, we're talking days and weeks, not months and years to make this change as we get more comfortable using 3D tools. The last section here is talking about potential future process improvements. As I've mentioned, this guidance document is going to be a living document where the intention is to continue to update it over time. Custom FDOT templates for rapid 3D modeling tools. This is actually already in the works, which is awesome. So we should be seeing more information about that. Tool-specific training, Eric already mentioned that as well. And then a more in-depth exploration of the potential 3D applicability items. Those are those items like the utility impact assessment report or other ones that were in that table where we said potential 3D applicability. So this would be exploring those more in depth to provide additional guidance for that. And then the references and the appendices are some of those graphics that Eric went through with our challenge questions and then the different efficiencies for PD&E process improvements. So with that, I will go back to the presentation and hand it back over to Catherine.
Thank you, Lauren and Eric. That was awesome. You did a great job. I had a couple remaining questions. One, I guess for you, Eric, it's like, how can you convert KMZ data to DGN format?
So
And if that's a
excellent
long
question.
answer.
Well, yeah, well, I'll keep it short. So
Okay.
I'd be curious what the source of the KMZ, because the KMZ initially is an export from a production application typically. So there isn't typically the need to go the other way. So I'd say in most cases we don't do that. There's a data degradation that takes place anyway in the process of moving it from a production environment to KMZ for those visualizations there. So I said we probably wouldn't do that.
Okay. And thanks, Eric. Also, there's a question about, well, there's a question, just a suggestion to reference FDM 124. And as Lauren mentioned, this is the living document. So we'll look at that and possibly add that reference as well. That was great. Another question was, what's going to be the QC process? And unless someone else knows a better answer, I'd say right now we're just learning. I don't think we have an answer to that yet. Eric, you're smiling. Maybe you do have an answer for QC
Yeah,
process.
I was reading that one, at the end. So my thoughts would be, when we're at that stage, let's say you are at your preferred analysis, your preferred typical section, right? And now you are beginning to develop the horizontal curve and maybe the vertical curve. The same processes that would apply to the roadway design could apply there as well, right? So if there's a checklist that your roadway production group utilizes that checks it against the design speed, I'd say utilize those same elements there.
Okay, thank you, Eric.
Mhm.
Another question is whether this presentation will be available to the OEM website. And yes, it will. It might take a week or two before we download it and get it out there, but it will be available. And then the last question was, we've been using 3D concept development and analysis since 2013. Are all the districts going to implement this for all projects or only for projects with subsequent funding phases? And that was from Frank. And Frank, the answer to that is this is not mandated right now for PD&E. It's a project by project and district by district decision. So as you get a new project, you guys will have to make that decision as you go forward. I don't know in the future and what the future is for mandating. It might be mandated in the next few years. I truly don't know right at this moment. So we are looking at all that, looking at, like I said, how to get efficiencies between PD&E and design. We're looking at some other things as well, just to make our PD&E more useful for design and have less throwaway information. So we're going to be looking at everything in the next year or so. And yeah, as we update this handbook, we'll be reaching out to everybody for more trainings like this. And all I can say is just try to keep up with us. We'll be letting everybody know if there've been changes to our processes, but right now there are no changes. And with that, I see we've gone over our time. I really appreciate all the great questions, and I appreciate Eric and Lauren. This is very exciting stuff. Nothing stands still anymore. So looking forward to seeing our projects in the future. And thank you guys. Thank you for tuning in.
Catherine. Thanks, everybody.
Thanks, everybody.